In this video, we will talk about the reasons why Earth experiences different seasons throughout the year. It is a common misconception that the slightly varying Earth-Sun distance is what causes the changes in seasons on Earth. This is not the case. In fact, Earth is closest to the Sun when it is winter for us in the Northern Hemisphere. We are then farthest from the Sun when it is summer in the Northern Hemisphere. In this animation, we are looking at Earth's orbit around the Sun from space. In the initial view, we are looking at the Earth and Sun from directly above the Sun. Notice that Earth's orbit looks circular. That's because it nearly is. The Earth-Sun distance does change, but it does not change very much, and certainly not enough to cause changes in Earth's temperatures. When our viewing angle is changed, Earth's orbit can appear to be oval. But that is just a change in perspective. Earth's orbit is very nearly circular. The reason we experience seasons on Earth is that Earth's axis is tilted relative to the plane of its orbit. The plane of the orbit is shown by the thick white line above. Think of that line as being like the edge of a dinner plate that is perpendicular to your computer screen. If the Earth's axis had no tilt, the north and south poles would be lined up with an imaginary line running perpendicular to that plate. Instead, Earth's axis is tilted by 23.5 degrees relative to this imaginary line. The tilt of Earth's axis has two effects. One is that the intensity of sunlight changes throughout the year. Two is that the number of daylight hours changes throughout the year. We will discuss both of these effects in more detail in this video. Now we will look at a simulation that shows Earth's orbit around the Sun and how that changes the intensity of and number of hours of daylight we have throughout the year. A link to this simulation is available on Canvas in the Seasons module and is also shown here. Here is a snapshot of the simulation. The left panel shows the view of Earth and Sun from space. In Earth's current position, the Northern Hemisphere is tilted toward the Sun, so it is summer for Northern Hemisphere inhabitants. On the upper right, you can see a close-up of the angle of the Sun's rays hitting the Earth. The stick figure on Earth shows the location of the observer, who is at latitude equal 38 degrees, the latitude of Pleasant Hill. Notice that the sunlight is hitting the Northern Hemisphere more directly. The bottom right panel shows our view from Earth. The arrows represent the angle and intensity of the sun's rays. Since the arrows are nearly perpendicular to the ground, that means the sun is high in the sky, but not directly overhead. Since the arrowheads are closer together, the sunlight is more intense that day. Now you can watch the change in each panel as the Earth orbits the Sun over the course of a full year. The animation starts with the spring equinox on March 21st. Notice that as time progresses, the Sun's rays become more upright and closer together. This corresponds with an increase in the intensity of sunlight and the number of daylight hours as we approach summer. After summer, the Sun makes a shorter and shorter arc in the sky, so the Sun's rays arrows make a smaller angle with the ground. The sunlight is less intense and we have fewer and fewer daylight hours as we approach the next equinox in September, and then the winter solstice in December. On the date of the winter solstice, the sun will make its shortest arc in the sky, causing the least number of daylight hours and the least intense sunlight. Based on what you just learned, you should now be able to label this diagram. See the notes handout for the labels you should use in order to use this as a study guide. To get you started, the dates of each of Earth's positions are shown. Also shown is a light blue line that corresponds to the equator on Earth. We will review this in class the next time we meet. Let's look at the changes in the sun's intensity and the number of daylight hours in summer versus winter. On the left, the summer season is shown. Note that the sun is relatively high in the sky. This means it will make a taller arc in the sky, and be above the horizon for longer. Recall from the previous video that the sunrise position is north of east during the summer months, so the sun will be above the horizon for more than 12 hours. Now look at the small circle of sunlight on the ground. This means that the sunlight is less spread out, so is more intense. More daylight hours and more intense sunlight cause warmer temperatures in the summer. On the right, the winter season is shown. Notice that the sun is relatively low in the sky. This means it will make a shorter arc in the sky and will be above the horizon for less time. Recall from the previous video that the sunrise position is south of east during the winter months, so the sun will be above the horizon for less than 12 hours. Now look at the larger circle of sunlight on the ground. This means that the sunlight is more spread out, so is less intense. Fewer daylight hours and less intense sunlight cause cooler temperatures in the winter. The final part of the notes has to do with thinking about how seasons would change if the tilt of Earth's axis were radically different. This is your Canvas discussion question for this module. Stay tuned for our in-class discussion on this topic after you've had a chance to think about it yourselves. Have fun with changing our planet!